So let us start today's lecture. In the previous lecture we have discussed the semigroup generated by a set. Okay, the particular case is if A is a singleton set. If this A is equal to the singleton set, then you can say this, the semigroup generated by A will be A square, because it is the finite product of elements of the singleton set A, which is A, then A square, A cube, and so on and so forth. This is your semigroup generated by A. Okay, and it is said to be a monogenic सब सेमीग्रुप ऑफ एस. इसको हम कहेंगे मोनोजेनिक, जैसे साइक्लिक होता है ना वैसे जनरेट सिंगल एलिमेंट से. मोनोजेनिक सब सेमीग्रुप ऑफ एस. नाउ if there exists A in S such that this S is generated by that A, then S is said to be a monogenic semigroup. Then S is said to be a monogenic semigroup. Then S is said to be a monogenic semigroup. Okay, जैसे साइक्लिक ग्रुप होता है ना, यहाँ पर साइक्लिक सेमी ग्रुप नहीं कहते, यहाँ पर कहते हैं मोनोजेनिक सेमी ग्रुप. So we have our S is equal to this one, A square, A cube, and so on and so forth. So there may be repetition or there may not be repetition. Two cases may arise. If there is no repetition, then S is infinite. Okay. If there is no repetition, okay, if a power I is not equal to a power j for all I not equal to j, or if a power I equal to a power j implies I equal to j, then we say that there is no repetition, and in this case this S is an infinite monogenic semigroup. So we have a theorem. हम theorem की फॉर्म में सारा करेंगे. So we will explain it in the form of theorem. Theorem. Let S be generated by A. Then either all the powers, then either first part, all powers of A are distinct, all powers of A are distinct, all powers of A are distinct, and the monogenic semigroup and the monogenic semigroup is isomorphic. In this case it's isomorphic to semigroup of natural numbers under addition n plus. Okay, second case, if there is a repetition, either this holds, all the powers of A are distinct, or there is repetition. In that case, what we obtain positive integers m and r, or there exist positive integers m, the index positive integers m, the index of A and r, दूसरा इंटीजर r एक्स्ट होगा, पॉजिटिव इंटीजर्स m and r. This r is called the period of A. It's called the period of A, index of A and the period of A, such that the following properties hold, such that the following properties hold, such that the following properties hold. फर्स्ट केस, अगर ये डिस्टिंक्ट हो गया पावर, उस केस में ये आइसोमॉर्फिक होगा m प्लस के साथ, और सेकंड केस अगर इसमें रेपिटेशन होगा तो दो पॉजिटिव इंटीजर्स एक्सिस्ट होगी, वन इज m विच इज कॉल्ड द इंडेक्स ऑफ A एंड सेकंड इज r विच इज कॉल्ड द पीरियड ऑफ A, सच दैट द फॉलोइंग प्रॉपर्टीज होल्ड. नेक्स्ट पेज पर मैं आ जाऊं?
यस सर.
ओके, so first property is A power m is equal to A power m plus r. This is the first property. Second property is for all uv in n0, n union 0 can say, so they may be 0, okay. U and v, they are non-negative integers. U and v varies from 0, 1 to, this is the variation of u and v, and 0. A power m plus u is equal to A power m plus v if and only if u is congruent to v mod r. Zero, yes, natural numbers with zero. And third part, in this case, the monogenic semigroup generated by A is equal to this. It's finite because we have a repetition in this case. It's equal to a square A power m, again we continue, it's up to A power m plus r minus 1, A power m plus r minus 1. And fourth property is we can define K subscript A. It is this set. It starts with A power m plus 1, A power m plus r minus 1. This set, it's a subset of the monogenic semigroup generated by A. This one is a cyclic subgroup, of this semigroup generated by A. It's a cyclic subgroup of this. So let's prove the first in case there is no repetition. Okay, proof. If all the powers of all the powers first part, okay, first, if all the powers of A are distinct, then A power m is equal to A power n. It implies that m should be equal to n. Okay. So therefore in this case the monogenic semigroup generated by A is infinite set, A square, and so on and so forth. So now we define a map from n plus to A generated by A. Define f from n plus to this monogenic semigroup A by nf is equal to A power n. A power n. A power n. Okay. So you check this map is 1 1 onto and homomorphism. It's very simple. You can do this. You can do this. It's very simple. Okay, then this f is an isomorphism. You verify that f is an isomorph. It's very simple. Verify that f is an isomorphism. Okay, so therefore this is isomorphic to n. Okay, it's very simple. You can do this. Now we prove it second part. Okay, ये आपने किया कॉपी सारा? Okay, so let's prove the second part. So second part means that there is repetition. If if all the powers of A are not distinct, if all the powers of A are not distinct, then obviously there is repetition. So then there exist positive integers I and j, with obviously I is less than j, such that a power I is equal to a power j, which is equal to a power I plus some r, where this r is greater than 1, greater or equal to 1, because j is greater than I. Okay, j is greater than 1. Okay, now we define a set. Consider a set consider the set, this set, those integers I such that a power I is equal to a power I plus r. Okay, this r is greater or equal to 1. Then this set is non-empty. It's a set of a non-empty set of positive integers. Therefore, it has least element. Okay, let's denote this set by say A. ये सेट आपको समझ आ गया? ये सेट मैंने क्या दिया, वो इंटीजर्स आए जिनके लिए ये प्रॉपर्टी है. बहुत सारे इंटीजर्स होंगे आई जे, बहुत सारी पेयर्स ऐसी होगी जिनके लिए ये ट्रू होगा. आपको समझ आ रहा है ये? हेलो, ओके. आप मुझे लग रहा सो गए हो शायद. ओके, सो नेक्स्ट पेज. then A is a non-empty subset of set of positive integers, set of positive integers, and therefore A has the least element. A के पास least element होगा. A has the least element. Let M be its least element. Let M be its least element. Let M be its least element. Least element. And we call it the index. And we call it the index of the element, and we call it the index of the element A. Now consider the set. Now we consider another set. Now consider the set B, which is equal to R, which is equal to J, such that A power M is equal to A power M plus J. अब ये वाला वैरी होगा. This J is obviously greater or equal to 1. Yes. हाँ बताइए. M एग्जिस्ट हो गए ना M. अब A पावर M इक्वल टू A पावर, जैसे A पावर I था A पावर I प्लस J, A पावर I वाज A पावर I प्लस R से, तो I का मैंने लीस्ट चूज किया M, सो A पावर M इज इक्वल टू A पावर M प्लस R. अब मैं यहाँ पर J चूज करूँगा क्योंकि मुझे R एक्चुअली इसका लीस्ट एलिमेंट लेना है. or you can choose g. A power m is equal to a power m plus g. Then this set is also non-empty. Then this b is non-empty subset of set of positive integers, set of positive integers. Okay, set of positive integers, set of positive integers. Okay, therefore this b has the least element. आप इसको पहले नोट कीजिए, इसको कॉपी कीजिए पहले. तो मैं नेक्स्ट पेज पर आ जाऊं.
Yes, sir.
ओके,
सर ये लीस्ट एलिमेंट है ना.
हाँ हाँ. Therefore m is the least positive, therefore least element of a, therefore b has the least element, b has the least element. Okay, let r be the least element of b, be the least element of b, and we call it the period of the element a, period of the element e. So thus we have this a power m is equal to a power m plus r, where m and r are the least positive integers satisfying this equation. Okay, where इसका नाम आप 1 रख दीजिए, where m and r are the least positive integers satisfying first. तो पहला पार्ट आपको मिल गया, a पावर m, देयर एग्जिस्ट m एंड r विद दिस प्रॉपर्टी a पावर m इक्वल टू a पावर m प्लस r. अब इसका सेकंड पार्ट आपको चाहिए. सेकंड पार्ट में कह रहा है if you and v are non-negative integers, then a power m plus u equal to a power m plus v if and only if u is congruent to v mod r. तो नेक्स्ट पेज पर मैं आ जाऊँ.
Yes, sir.
नेक्स्ट we verify that if u and v belongs to n0, then a power m plus u is equal to a power m plus v if and only if u is congruent to v mod r. So first assume that u is congruent to v mod r. Then r divides u minus v, which implies that there exists a positive integer, there exists integer, हम लिखेंगे, not necessarily positive. There exists an integer q such that u minus v is equal to qr. u minus v is equal to qr. This implies u is equal to v plus qr. U is equal to v plus qr. This q is positive integer, okay? Choose q, there is positive integer आप लीजिए, because this u is congruent to v, we choose u minus v to be positive. There exists a positive integer, okay? Positive integer q. Okay. ओके नेक्स्ट पेज पर मैं आ जाऊँ.
जी सर.
So u is equal to v plus qr. This implies that a power u is equal to a power r plus qr, which implies that multiplying throughout by a power m, it will be a power m plus u equal to a power m plus r plus qr, and this implies it's a power m plus u equal to a power, it should be here v, it's v here, it's v, it's v here, okay, it's v, it's a power v into a power m plus qr. So this implies a power m plus u is equal to a power v into a power m. You can verify this a power m plus qr is equal to a power, आपको ये verify करना using this a power m is equal to a power m plus r. Okay. So it implies that a power m plus u is equal to a power m plus v. आप ये वेरीफाई कीजिए, ए पावर एम प्लस क्यू आर इक्वल टू ए पावर एम फॉर एवरी पॉजिटिव इंटीजर क्यू. यस
सर हम उससे इसको लिखेंगे a to the power